Hello, in this video we are going to see how you can simulate the group delay of UWB antenna using CST. So in our previous video about the UWB antennas, we have seen that group delay is one of the important characteristics of the UWB antenna. So group delay is the time it takes for a specific frequency component to travel through the system, and the main characteristics that UWB system has to obey is all the frequency components must experience the same time delay. That means that group delay has to be a constant for every frequency component. To get more details, you can watch that previous video. So in this video, we are going to see how you can simulate that. So usually if you want to simulate the group delay, we arrange two UWB antennas like side by side or face by face. So the distance of separation between these two antennas are more than the far field. So here what we are going to see is if a wave is transmitted from this transmitting antenna and if it is received on the receiving antenna, the group delay of all the frequency components has to be like a constant. That is what we have specified in our previous video. So this is what we have to see in our simulation. So for that we need two antennas, that is this type of arrangements we usually arrange that in side by side or face to face. So this is our previously simulated antenna. If you want to calculate the far field, we know that we have to use this equation 2d square by lambda, where d is the largest dimension of the antenna. In this case, the largest dimension is this diagonal and it is around 57. So I have used this calculator to calculate the far field and I have put these values here, and I have used the highest frequency, then the wavelength will be very small and we will be getting the better means larger far field. So I have used the high frequency here, that is in UWB antennas the frequency is from 3.1 to 10.6. So I have used this frequency. So here you can see that the distance of separation has to be around 220 mm. So let's see how you can do that in. So I have taken the previous simulated model. So I'm going to take the component one, that is everything together, the dielectric ground and patch. So I'm going to transform that into the far field. So I'm going to use the two antennas in face-to-face orientation. So I'm going to rotate this antennas so that I have two antennas. So the rotation is around the y plane. Okay, so I have rotated two antennas. And I'm going to move this component one, which is the rotated antenna, to around 220 meter. So is that this 220? Okay, where is the thing? Okay. Am I rotating the correct one? So this is the component one. Okay, so I have to rotate this one itself. So I'm going to rotate this to 220. Okay, let's see that. So we have the two antennas here, one antenna and the other antenna. So both the antennas are facing each other. So I have to assign the port here. So for that I'm going to select the face. Sorry, select these 2 points. Okay, then I'm going to, so the same setting as previous. So no other things. Okay. So this orientation has to be Z, and so you can assign the port as what you are expecting. So here we have assigned the port and you can see the arrow direction is inwards, and click OK. So we have two antennas with port assigned to them now. Okay, port 1, port 2. Okay. So now what we have to do is we have to set the post processing for the group delay. So here if you go for the result template, you can choose filter analysis. So in filter analysis, when you go here, you can see group delay time. So this pop-up will appear. So it is asking which port we have to consider. So you can give the option like from port 1 to port 2. So if you have more number of modes, you can change it here. Now it is like from port 1 to port 2, the group delay will be calculated. Okay. So if you have a good computer system, you can maintain high mesh settings, but for me the mesh settings is very low because my license is a learner's license, so my result will not be accurate. I am just showing the workflow. My result will not be accurate here. So you have to use good setup, like you have to use maybe 12 here, something like here, to get the good result. Okay. And if you run the simulation, you will be getting the results in tables. So here I have simulated these structure, the same structure with less mesh setting, so my group delay will not be correct. So you can see here that in tables the group delay results are stored. Here you can see that the group delay, how the group delay is varying from different frequencies. Here you can see that the group delay is almost same. There is only very minor variations. So here you can see that the group delay is in nanosecond units. So here you can see that how it is varying. So you have to use good mesh settings, and then you will be getting the group delay here. One of the main thing that you have to consider here is which is the post process. So you have to use the go to the result template and use the filter analysis. So this is how the group delay simulation is done in CST. I hope you get some idea. Thank you.